Alright, so in this lesson we're going to look at the volume using the disk and the washer methods, two different methods. So we've already seen how we can use an integral to approximate the area under a curve. So what we're going to do is take that idea, and so hopefully we all realize we could find the area of this using an integral. We can go back to those notes in chapter 4 and look at how we did that with a horizontal line. And if we take this rectangle and if we rotate it around the x-axis, we get this shape right here. And so we can do a couple things to find the volume of this disk. Alright, so the volume of the disk is going to be the area of the disk times the width of the disk. Or back in geometry we did the area of the base times the height. So this would be the area of the base times the height. If you wanted to, you could look at it that way, and we have the area of the base times the height. Okay, so that's what we're going to have for the volume. But then we can look at the change in the volume. So we could put more disks in there. Just like when we wanted to find the area, we put more rectangles until, so we take the sum of all those disks that we're going to have, and we can, so that's one disk, that's the change in each disk, and then this is adding up a bunch of disks, and we can factor the pi out here, and then if we take the limit as the number of disks approaches infinity, we get this formula right here. And so that's what we need to use. So we're just going to, anytime we're rotating around, revolving around, obviously if you revolve around, that's going to give you a circle, and so that's going to give you pi r squared. And so that's all it is. It's pi times the radius squared. And then the dx are all the widths of the rectangles, and so that's going from A to B. So that's kind of the height. So it's pi r squared h, basically. We can also do this in terms of y if we're revolving around a vertical line. Now there's all kinds of different scenarios. Depending on where the lines are, there can be some things that get a little bit trickier. So let's see what we have here. So find the volume of a solid formed by revolving. So as soon as you see the word revolving, that tells you you have pi there, and as soon as you see the word volume, so volume, you have an integral, and revolving, you have pi. And we're doing the graph of the square root of sine of x and the x-axis from 0 to pi, so it's telling you that also. Okay, now here at the end it says we're going to be revolving around the x-axis. So what I want you to do is think about the x-axis, think about the equation of the x-axis. The equation of the x-axis is y equals 0. And so what we want to do is do the opposite of this letter. So this is y equals 0, so that's going to be dx. Alright, and so let's graph that real fast. So 0, the sine of 0 is 0, the square root of 0 is 0. The sine of pi is 0, the square root of 0 is 0. The sine of pi over 2 is 1. And the square root of 1 is 1. So that's right here. Now this is not to scale because pi over 2 is 1.5. So if we wanted to make this a little more visually accurate, we could have spread this out a little bit more, because this is 1 and this is approximately 1.5, but this will have to do. So pretty much looks like the sine curve from 0 to pi, except it's stretched out a little bit, or fuller. Okay, so what we're doing is we're going to revolve this around here. So we'll just put in a radius. So that's the radius, and if we revolve that around here, we get, looks almost like a basketball or whatever, except it would be wouldn't be perfectly spherical, but so you can imagine those little slices going across there maybe. So the radius that we're revolving around is this y value here, which is the square root of sine x, and that's the radius squared, pi r squared times h. Okay, so if we square that, we just get sine. I guess I could write that again. It seems a little bit redundant, but or obvious maybe. So if we integrate this, that's going to be negative cosine x, because the derivative of cosine is negative sine. Since this is positive, we must have had a negative here, because the negative sign and a negative would be positive. And now we're just going to plug that in. I'm going to factor the negative pi out, so we're going to have the cosine of pi minus the cosine of 0. So you got to be careful here. Don't assume that plugging in 0 is going to give you 0. It does not in this case. So the cosine of pi is actually negative 1 minus, and the cosine of 0 is actually 1. So now we have negative 2 times negative pi. So that's going to be 2 pi. Alright. Okay. So now if we look at the next one, okay, we're going to go through this process again. So now, find the volume. So again, just memorize it. So much of math is memorizing certain things. Now there's more to it than that. Higher levels of math, you can be much more creative and figure stuff out. But at our level, it is really mostly just memorizing a process. So volume is integral. Revolving is going to give us pi. Now, where we're going from is a little less clear. We're going around the line y equals 1, so we're going to do the opposite of that. So that's going to be dx. Okay, so now the best thing for us to do probably would be to graph that. So if we graph this, this is a parabola reflected over the x-axis and then shifted up 2. Or you can plot a couple points. So plug in 0, you get 2. Plug in 1, you get 1. So that would be here. We have the axis of symmetry there, so we could reflect that over there. And then, or we could use the pattern over 1 down 1, over 1 down 3, 1, 2, 3. That would be right here and right here. Okay. Now, that is being revolved around the line y equals 1, which is right here. Okay. So when you revolve that, you're going to get this. Now it should be a little bit steeper there, but so that kind of reminds me of the eye of Sauron in the Lord of the Rings on top of the tower. But anyway, maybe, or like a lemon drop, a little less ominous, kind of a lemon drop shape there as you rotate that around and make it three-dimensional. So now we can see where these two intersect. They're intersecting at -1 and 1, so we're going to go -1 to 1. And now we can go back to the last lesson and think about the top minus the bottom. So if you think about it, also what we're trying to find is this radius right here. So a lot of times I draw the radius on there so I can see what exactly I'm trying to get. So what is that length right there? That's the top minus the bottom, which are these two things. Okay. Now it just so happens that the line y equals 1, actually the line that we were revolving around is the same as this bottom chunk right here. So that's a coincidence that those two were equal. So the top is 2 minus x squared minus the bottom, that's going to be -1. So the biggest thing is setting those up. Sometimes they just have you set them up on the test. They don't even have you solve them sometimes, but okay. So now, before we do that, let's think for a moment This has symmetry on both sides. This side's going to be the same as that side. So since it has symmetry, maybe it would make more sense to multiply this times 2 and go from 0 to 1 instead. Hopefully that makes sense to everybody, because obviously it's going to be nicer to plug in a 0 than to plug in a -1. And so we can just double the volume, because the volume over here will match the volume over there. And this is what? 1 minus x squared. So we have 1 minus x squared squared. So that's going to be 1. Multiply those together and double it. So that's going to be minus 2x squared, and square this. That's going to be plus x to the 4th. Alright. So we have the 2 pi out here. And if we integrate that, that's going to be x. Add 1 to the exponent. Divide by the new exponent. Add 1 to the exponent. Divide by the new exponent. Okay, so if we plug 1 in there, we're going to get 1 minus 2/3 plus 1/5 minus, and we would get 0 over here, because if we plug 0 in for all those, that would be 0. Okay, so getting a common denominator here, it looks like that's going to be 15. So if we multiply this, I have to multiply by 15 over 15. This we would have to multiply by 5 over 5. And this we would have to multiply by 3 over 3. So that looks like 16 pi over 15. So the one adjustment we had to make up there was we had to realize that because we were revolving around y equals 1, that changed what the radius was going to be. We weren't going all the way down to here. Okay. Alright. Now, this looks a little bit different than yours because I added a graph down there. So, but other than that, it's the same. So now what we have is a washer. Alright, so I have a washer at school, so I figured I probably had one in my garage somewhere, so I went down and looked for it. And so here's a washer, and so what's called the washer method, because that's simulating these discs with a hole in the middle. So we might have an object that has a gap inside of it, and so we're going to use this technique, which is fairly similar to what we were doing before. So really, what you should do is think about the volume of the whole thing. Pretend there is no hole. And so we're going to find the volume of the total, and then we're going to subtract out the volume of the hole, of the part that's missing. Okay, and you notice how we have the square, so we have the pi r squared with this height for the whole thing minus pi r squared for the hole, and we use lowercase r for the inside and uppercase r for the whole thing there. So I'm going to draw a graph real quick, and then we'll do this one. Alright, so let's go one step at a time. So find the volume. Okay, so integral. Find the volume. Revolving, so we're going to put pi. Some other stuff here, we're going to graph that. About the x-axis. The x-axis is y equals 0, so that's going to be dx again. So keep that in mind, dx. Okay, so let's see what we're looking at over here. So we got y equals x squared. So 0, 0, 1, 1. Okay, so that looks like something like that. Okay, so that's x squared. Let's do, that was in blue. Let's do y in red. And so that's a square root of x. So that's also 0, 0, and that's also 1, 1, but that's going to go this way. Okay. Actually, those should be a little more symmetric if I did it properly, but okay. So that's being revolved around the x-axis. So that's going to come down here, and we could do this over here. Guess I could have done those in the same colors. They were like that. So if we rotate that around the x-axis, we're going to get that, which might be hard to visualize. So that there's this little, they used to have at the Children's Museum this thing, and you sometimes you see in other places where you like throw a penny in there or a coin and it rolls around and around and around. Big funnel thing, big. I think it was yellow if I remember correctly, and it would just go around and around. So that's kind of what the hole looks like. That's the gap there. Looks like a weird bowl with a side that puffs out instead of in. Not sure how well you can see any of that three-dimensionally. So that would go all the way around, though. It would have that thickness all the way around. Sort of like a bowl, I guess. And this part in here is missing. That's not there. Okay, so we're on dx. So we're going from 0 to 1. So that's going to be 0 to 1. Now we're going to pretend that there's no hole. So we're just focused on the red right now. So the radius of the red would be all the way up to there. And that is the square root of x. So that's going to be the square root of x squared. And then we would put dx. If there was no hole, we'd be done. That's it. But we also have the volume of this funnel thing here. And the radius of that is the blue line that I just drew there, which was x squared. So that's going to be minus x squared squared. Okay, and then dx. So once again, that's the same thing we've done twice already. If we were to find the volume of the whole thing, minus the volume of the whole. So this is just x, and this is x to the fourth. So that's going to be 1/2 x squared minus 1/5 x to the fifth from 0 to 1. So that's going to be pi times 1/2 minus 1/5 minus, and then really I should be using parentheses here probably just to emphasize to you, minus, and technically that would be 0 minus 0. So we just want to be careful with that. So getting a common denominator here, that's going to be 10. So this needs to be multiplied by 5 over 5. That's going to be 5. This needs to be multiplied by 2 over 2. So that's going to be 3 pi over 10. Okay, we have 2 left. Okay, so yours don't have graphs on them. You might want to wait and see how I put what scale I put on here, but so I'm going to call this 2, so I'm going to go by 1/2. So that's going to be 1, and this is going to be negative 1 right here. Okay, so now find the volume. Okay, so bam, volume, that's going to be an integral. Revolving, that's going to be pi. Now it's going to get a little tricky here. Okay, so let's graph this and start to get a little picture of this. This is a parabola shifted up 1. I already said my scale is 1/2 here. And then if we plug in 1, we get 2. So that is going to look like this. Alright. And then we're going from 0 to 1. So that's right here. And we're going to rotate that around. The y-axis. Now, so here's a change. We're going around the y-axis, which is x equals 0. So the opposite of x is actually dy. So we're going to go on y here. We did one of those area between two curves on a y. So we're going to look at this. So we're revolving this around. So first of all, let's do that. So that looks like a bowl. That looks better as far as a bowl goes. And this would be over here. And we'd revolve this around also. Like that. And I'm going to put a circle around here too, revolving it around here, just to kind of accentuate what's happening right there. Okay? So what we're looking at here is, because it says around the x-axis, the y-axis, which is x equals 0, we're going to go dy. So we're focused on it like this. Now, as you look at that, I hope you all see that the first, from 0 to 1, those are all disks. Those are all solid. Okay, and then once we get to 1, then they start to be washers because we have this bowl cut out. Another way I talk about this is if you go to Baskin-Robbins and if you imagine that they dug the ice cream out perfectly and scooped the ice cream out, so that would be a big canister of ice cream, and then this part has been scooped out on top perfectly smoothly into a paraboloid. Anyway, so from 0 to 1 on y, we're going this way, well there our radius is just 1. It's just a cylinder. That's actually, we could just do the volume of the cylinder right there. Pi r squared h. R is 1, h is 1. Anyway, so we'll get the same thing, that's fine. Okay, then when we get to the next section, we're going to go from 1 to 2, and now we have the volume of the whole thing. So the whole thing would still be 1 squared, and then we need to take out the scoop, the hole. So that's right here. So now that's a little bit trickier. So what I need is, I need this height, but I need it in terms of y. So we need to take this, and we need to subtract 1 from both sides, and then we need to take the square root of both sides. So x is the square root of y minus 1. And we get the plus and the minus, but we only need the 1 because we're rotating it around to get the whole thing anyway. Okay, so that, if we were just finding the volume of that paraboloid, we would just need that radius, which would be y minus 1, square root of y minus 1 squared. Okay, so 1 squared is just 1, so if we integrate that, we just get y, so that's pi times y from 0 to 1. And if we plug in 1 and 0, we just get pi, which we could have solved for that way back in geometry. Just find the volume of that cylinder. Pi r squared h. R is 1, h is 1. Just would have got pi. Okay, plus, now what do we have over here? We have this squared, and that's I'm going to lose track of some stuff in here. That's going to be 1 minus y plus 1. So that's going to be 2 minus y. So we have the pi from there, and now 2, if we integrate 2, we get 2y, and if we integrate that, we get this. Okay? So, if we plug 2 in there, we're going to get 4. If we plug in 2 here, 4 minus 2. So that's that. And then, parenthesis, because I got to distribute this negative, so plug a 1 in there, that's 2, and then minus 1/2. Okay, so this is going to be plus, that's pi. This is 2, this is 1.5, so minus 1.5. 2 minus 1.5. So that's going to be, so 2 minus 3/2 is 1/2. So that's going to be 1/2 pi. 1 pi plus 1/2 pi is 3/2 pi, or 3 pi over 2. Okay, and we just have one left. So, alright, so our last example for the day. So once again, 5th time, volume. So volume means we're going to be taking the integral. Revolving. So revolving means we need to have pi because we're revolving. We're going to be creating circles. So we need pi here. The region bounded by the graphs of this. So we're about to graph those and see what's going on. Notice how on the scale here, oops, I need to spread that out. So actually I want that 1 to be right here and the 2 to be over here. So ignore the first one and the first 2 there. Okay, so we're revolving around the line y equals -1. So that scale I need to keep the same because you'll see why in a minute. So that's the line we're revolving around. That scale is just going to be 1, 2, 3, 4. Okay, so we're going to do the opposite. So we're doing dx. And we're going up to the line x equals 2, and this starts at 0. So we're going from 0 to 2. And if you don't see that yet, you might see it better when we have the graph here. So now if we plug 1 into this equation, 1 squared is 1. So 1, 1. And if we plug 2 in, 2 squared is 4. So that would be 1, 2, 3, 4. Okay. So there's our graph of that. Now, we're going to revolve that around this line. So that is going to look like this. So here, this point is going to be revolved down here, so that will be there. Then this point was 2 above that line, so it'll go 2 below. And this is 1, 2, 3, 4, 5, so I need to go 1, 2, 3, 4, 5. Basically reflecting those points over the line that we're revolving around. And so here, this will give us a big circle as we revolve that around. And so what that does is it creates this hole in the middle. And let me highlight that so it stands out a little bit more. So we're going to have this and this. So that reminds me of a couple things. Maybe like a Christmas tree stand if you look at it. You put the trunk of the Christmas tree in there, or maybe a little volcano project you made when you were in elementary school. So I'm just trying to help you visualize what that would look like three-dimensionally. Okay, so hopefully that makes it pretty clear. That's going to be a washer, the washer method, like the washer I found in my garage to show you, right? The hole in the middle. Okay, so let's get back to it. So we pretend that the hole is not there first, and we find the volume of the entire thing. So the trick here is that we're coming down to y equals -1. So I told you it's going to be hard to see it here, but so there's the radius from the line of revolution to the graph itself. So if you think about that distance, that's going to be still top minus the bottom. So the top is x squared, so that's going to be x squared minus the bottom is -1. Now you could just see that if we take x squared and we add 1 here, that's +1 to the length. But technically, just in case it's not -1, we want that to apply to anything. So that's our radius, and then we need to square that, pi r squared times the height. So that would be our formula if we did not have this hole here, but we do. So we need to subtract that out. So that's going to be minus, And now we just need the radius of this, which is super nice. It's just 1. So that's going to be 1 squared. And we are almost so close to being done here. So now if we square that, that's going to be x to the 4th. And this is x squared plus 1. So when we're squaring a binomial, you square the first thing, you multiply these together, and double that. So that would be 2x squared. And then you square this. That would be plus 1. But then we would have square this, and we would subtract. So that would be minus 1. So those are going to cancel out. So now we're going to integrate this. Add 1 to the exponent, and divide by the new exponent. Add 1 to the exponent, divide by the new exponent. And we have pi there, and 0 to 2. So if we plug 2 in there, 2 to the 5th is 32, hopefully. And then 2 cubed is 8, so that's going to be 16. And then luckily the 0 will just be 0. So not luckily, nicely, whatever. Alright, so if we multiply this by 3 over 3, we're going to get 156. If we multiply this by... Okay, so I multiply this by 5 instead of by 3, so that's not good. So if we multiply, to get a common denominator, we multiply this by 3 over 3. So that would be 96. Okay, so that's a little bit better. I was kind of worried there for a moment. Alright, so 96. This we multiply by 5 over 5, so that would be 80. And that would all be over 15 and then times 5. So that's going to be 176 pi over 15, and that is the correct answer. So it's about that time. Have a good day. Don't worry about these page numbers. I printed out the new pages with the graphs, so your page is 147. All right. Have a good day.